Hey guys, in this video we will be looking at solving rational equations, okay? So let's go ahead and begin. Let's look at A. It says solve each rational equation and then check each solution for reasonableness, okay? So the first thing is to identify the difference between simplifying and solving rational expressions and equations is that we will solve equations, but we will simplify expressions, okay? So when you have an expression like we've had before where it was just factor something and simplify it, there wasn't an equal sign. You weren't actually solving for x equals something. You didn't have an x equals answer. You just had a simplified form of a fraction kind of answer. But solving rational functions, when you see this word solving or equations, that is, we're going to find x equals what? It could be one number, it could be a couple of numbers. We're finding, in other words, the answers to this written equation, okay? One more time, so that solving, you'll have an equal sign that you're basically going to have x equals something as your answer. All right, so let's go ahead and begin. Some steps are the same when it comes to solving rational equations like we've done before. For instance, we're going to go ahead and begin by factoring all the pieces that are factorable. Okay, so this difference of squares, this is going to be written as x plus 3, x minus 3. Okay, everything else is the same. So we have 2 up here. We have x over x minus 3. We have x over x plus 3. And we're going to go ahead and solve for our x. So here we go. When you have a piece like this, there's two ways that you can do it. You can get a common denominator so that it looks like the right side of the equal sign, if you will, which I'm going to show you how to set that up right now. You can multiply, let's look at the denominator pieces. This has x plus 3, x minus 3. Well, this one only has one of those, okay? So let me go ahead and make some room here. Let me move this over. And this one right here only has one of them too. It doesn't have both of them the way it does on the right side of the equal sign, okay? So I can multiply by forms of one that has, well, this one needs an x plus 3 because now this is the same as this over here, okay? And then this one over here needs an x minus 3 because, again, now this is the same as this, okay? They're all the same now. And then from here, I can get the following. First of all, if these are combining because they're the same common denominator, I can go ahead and write that right here. Okay. And then nothing has happened over here. It's still the same. And then now it's all about, well, let's work with these numerators over here. We're going to distribute this to get x squared plus 3x. We're going to distribute this to get x squared minus 3x. And right here, we are adding all of this. So we don't need this parentheses that has been important if this is subtraction. So I can just go ahead and write adding that. Okay, so let's combine like terms. We have a positive 3x, we have a negative 3x. Well, that's going to zero out because those are additive opposites, if you will. Okay, so then we have x squared plus x squared, and I'm going to get 2x squared. So x squared plus another x squared is going to give me 2x squared. Okay, so now, the way we just did this is one method to do it. Our denominators are the same. So if they're the same, we don't even have to look at them anymore, okay? It was almost like back when we did exponential functions. If we had something like the base was 2 and it was x squared plus 1, and then over here the base was 2 and it was just x, well, then we no longer had to look at these because they're the same. All we did was set the tops, the exponents equal to each other, and then we solve for that, okay? That's kind of the same that's going on over here. If the denominators are the same, then just look at the numerator pieces. Set those equal to each other. These kind of like cancel, okay, if you will. They're negligible, okay? Just like this stuff up here. So now when I divide by 2, I'll get x squared is equal to 1. And please remember, I know it's been a minute, this is not just 1. When you have x squared is equal to a constant and you initiate this radical symbol on both sides, there's a plus and minus on the constant side. So this is actually plus or minus. Well, what's the square root of 1? The square root of 1 is 1. So x is equal to positive or negative 1. That's the answer to this here. The only thing that we have to do is check these answers and say, are they reasonable? Can I plug them in? And this is how you check if it's reasonable. If you plug in 1, let me go ahead and highlight this in purple. Here, it does not give you a 0 in this denominator. If you were to plug in 1 here, it does not give you 0 in this denominator. Remember when we did restrictions, we were saying what x could not equal, okay? Because it would be dividing by 0, it would be a discontinuity because it would be undefined. That piece would be undefined. You cannot divide by 0. And if you put a positive or a negative 1 right here, here, or here in the denominators, it's not going to zero out any of these denominators. So it shows that nothing's restricted as far as from these two answers. So the answers are x is equal to positive and negative 1. Now, let's look at something because there's a shortcut. To all this work, there's a shortcut, but it's if and only if you understand what's actually happening right here that I kind of related to this negligible piece of not looking at the base example when we did exponents in last unit. Okay, so here's the thing. If you're looking like at this step right here, and I asked you to get rid of those denominators, well, what would you multiply by? Think about it. What would you multiply by that made these denominators negligible, that they went away? Well, what you would multiply by is called, let me show you. First of all, I'll write what you would multiply both sides by. You'd multiply this by x plus 3, x minus 3, and you would do the same to the right side. So I can write it over here, x plus 3, x minus 3, okay? And the reason why you would multiply that is this is over 1. It's not over itself. This is not a form of 1. Okay, that you can do with expressions. That's a huge difference. Take some notes. Put that in your notes right now. You can multiply both sides by something that's not a form of 1 if and only if it's an equation. That means you're doing both sides of this equal sign. If you don't have an equal sign, you have to multiply by only forms of 1, where you would have to have this written on top and bottom. So there's a huge thing right there that you can put in your notes. If it's an equation, I can do what you do to one side, you can do to the other, or you must do to the other. We've learned that from Algebra 101, if you will, okay? So what happened? Well, this all canceled with this denominator, and only 2x squared was left over, which I wrote way over here, okay? And then the same thing happened over here. This whole piece canceled with this piece one at a time, like this x plus 3 with x plus 3, x minus 3 over x minus 3, and all I was left with was 2, which is what I had here. And that's what was able to give me my answer, okay? Or my answers, that is, positive and negative 1. Now, what is this called? It has a fancy little name. So it's called the least common denominator, okay? So it's actually LCD, and I know the notes show LCM. LCM is saying what is the least common multiple, and the least common multiple is the same as the least common denominator, okay? They're just saying that it's the denominator for these rational expressions because our goal is to cancel out these denominators. Okay, so LCD, LCM, least common multiple, they mean the same thing. Okay, so don't get confused whenever you see that in the notes. Okay, but I'm going to go ahead and call it the LCD. Okay, now let me show you how we can get to our final answer of positive and negative 1 very quickly if we know how to use this LCD. Okay, so let me move this down just a little bit, and I'm going to copy this original problem. We have x over x minus 3 plus x over x plus 3 over or equals 2. And I'm going to go ahead and factor this out, difference of squares, because I know that that's going to be a step no matter what I do, whether I do it the long way or the LCD way. Okay, here we go. So this way that I'm about to show you is the shortcut, if you will. I'm going to look at the least common multiple, otherwise the least common denominator, and I see it right here. Okay. Do not get greatest common factor mixed up with least common denominator. And you'll understand that when you do more practice. These are factors, okay? But their least common multiple, otherwise their least common denominator, is going to be this, okay? That's when they will be at least the most, let's say at the minimum point, they will have a common denominator at the very least right here. They will have a common denominator at the very least right here. That's why this is called a least common denominator. So now, if I multiplied everything, both sides, by this least common denominator, look what happens. That means I'm going to multiply this first piece by the least common denominator. I'm going to multiply the second piece right here. So I'm going to write it like this. And this is what's happening. I'm distributing it to here, and I'm distributing it to this second fraction. And what you do to one side, you must do to the other. So I'm actually distributing it, guys, on all three pieces. Now watch the highlights as I go through so that you can see what exactly is happening. If I multiplied it with the first one, the x minus 3's would cancel. So now I don't have a denominator for this first piece right here. Whoops, let me go ahead and fix that real quick. I don't have a denominator for this first fraction anymore. And all what's left is what's in blue. This will multiply with x because the x minus 3 is canceled. Okay, so that x squared plus 3x, that's what's going to be left over. X squared plus 3x. You got to see this a couple times. And I'm going to put this in parentheses just for now, and you'll see why here in just a bit. And I'm going to add, okay, that's this adding piece right here. Now I'm going to distribute this least common denominator on our second fraction. Again, they're separated by equal signs or addition and subtraction signs. When I do that, remember this is a form of x plus 3 times x minus 3 over 1. So pieces of this numerator, which in this case is going to be x plus 3, will cancel with this x plus 3. And what's left over is this x minus 3, highlighted in blue, is going to be multiplied with x. So that's x squared minus 3x. Okay? That's what's left over. So let me go ahead and write that over here. X squared minus 3x. And I'll put that in parentheses to show that that's the second fraction piece. Now, when I distribute our least common denominator, which is right here, across to the other side, I'm going to end up canceling the x plus 3's and the x minus 3's. So the only thing that's left over is an understood 1, which is way over here, that will multiply with this 2 right here. So we get this equation here. Now, I'm going to simplify this. If this was subtraction, yes, you would distribute. It's not subtraction here. So I'm just going to simplify this as far as, well, these parentheses would go away because the signs don't change. There's an understood positive right here, so those parentheses go away. And then when I combine my like terms, I have 2x squared is equal to 2. So x squared is equal to 1, and x is equal to plus or minus 1, which you get right here. It's basically doing all this work, but it does it in just one shot. By identifying the LCD, you have to identify what's the least common denominator. Okay, so real quick, just to make sure that we understood that, a least common denominator, let's say between, let's say 15 and let's say 5. So 15 would be 30, would be 45, would be, so what I'm doing right now would be 60 is I'm doing multiples. That's what that LCM was before that I said was very similar to, is similar to LCD. Here I'm doing least common multiple jump. So a multiple times 2 times 3 times 4 and so on and so forth. If I did the same, I'm like leapfrogging by jumps of 5. I'd have 10, 15, 20, 25, 30, so on and so forth. Because each multiple was by 5. Each jump, if you will, was by 5. Whereas up here, each jump or multiple was by 15. Now, the least common multiple is when are they the same? What's the lowest number that they're the same? Well, we know that they're the same at 30, but that's not the least common. We want the least common. They're the least common at 15. So the least common multiple is 15. And guys, that's what's happening over here. You have an x minus 3, and it's like jumping by x minus 3s, if you will. And the x plus 3 is kind of like also doing the same. But if you multiplied those together, this would be your least common multiple. Okay? One more time, because it's very important that you understand that. And it's highly tested on the SAT and ACT. And that's why I'm really trying to stress it for speed and accuracy with this. It's like looking at, let's say that I had 3 over 4 times 5/7. Okay, and I was like, well, what's the common denominator? What I'm really asking for is what's the least common denominator? Okay, well, you could do it the long way, like we did way up here, of getting forms of 1. So I'll have 7 over 7, and I'll have 4 over 4, so that I have 21 over 28. And let's say that this was adding, plus 20 over 28. So that you would have, what's that, 41 over 28, which you could just reduce it from there if it's reducible. Okay, that's what's going on here. But the fast way to do this, guys, is to multiply all of our pieces together that the denominators don't have of each other, if you will. And we've done this before. Let me show you what we've done. And as you get better and better, you'll notice places where you can use this and where you can't. Is that if I cross multiplied up, we have 21. If I cross multiplied up, we have 20. And then if I multiplied my denominators together, which is kind of like what LCD is doing over here, it's like multiplying our denominators together per se. It's a form of that. You get 28 and 28. You get it very quickly of what you got here, okay? So if you didn't understand that, please feel free to rewind, pause, and reflect a little bit, but that's pretty much what's going on and happening with LCM and LCD. Okay, solve the rational equation. Again, we see that keyword solve, so we're trying to find x equals something of some sort, and then check for the solution and the reasonableness. Now, looking at my question, I already see that our denominators are the same. It's like our least common multiple, if you will. So if it's the same, we can say, okay, well then those are negligible. We have x minus 1, x squared plus 2x minus 3. Let's go ahead and solve this out. So I can have x squared, subtract, add, and then have x minus 2, x plus 1. Factor. So that x is equal to 2 and a negative 1. We just have to now check our answers and see, do they actually work? So if I check my answers, the location that I'm seeing, will they work, are just the denominators, okay? Because I can't divide by 0 because it's undefined. So let's check the reasonableness, okay, for 2. Well, if I put 2 here, I got 4. That's good. That's legal. If I put 4 here, that's still legal because I still have 4. Okay, now let me see something real quick. I just noticed that I made a mistake, okay? And probably some of you are like hopefully already saw this mistake. If not, watch what happened. This 2 should actually be a negative 2, okay? And this 1 should actually be a positive 1. And I'll show you where I made that mistake. No worries, because I mean, when you do the homework, you will sometimes make similar mistakes. But this right here, when I moved the x over and subtracted it from a positive 2x, I should have had a positive 1x. That would have made this factor a positive 2 and a negative 1 to make those pieces happen. Okay, because watch, let me go ahead and highlight it. These two will multiply to get a negative 2. The first two multiply to get x squared. And then we still have our positive 2x, negative 1 to get a positive 1x. So these are correct, negative 2 and positive 1. Now, when I check the reasonableness, I cannot plug this negative 2 in because it would make that 0. And I cannot have this denominator piece right here equal 0. And it would make that one 0 as well. So 2, or negative 2 that is, that's out. Okay, it's extraneous. Remember we talked about that, where we'll still get an answer, but it is part of that restricted answer bank, if you will. Okay, so this is an extraneous solution. We cannot do that. It's an invalid solution. Okay, so 1 is going to be our final answer. Because if I plug 1 in, I can get 3 as a denominator. Remember, I just cannot get 0 as a denominator. Okay, so that is one way that we can do it. Okay, where we made the denominators negligible. If I multiplied by the LCM or the LCD, well, what is the least common denominator that they both have in common? It's like multiplying both sides by x plus 2 over 1. X plus 2 over 1. Again, it's not a form of 1. You're not saying x plus 2 over x plus 2. And I can do this because there's an equal sign. What you do to one side, you must do to the other. And when you do that, they don't have to be in forms of 1. Okay? Again, if there was no equal sign, then I have to do forms of 1 because I'm dealing with expressions. Well, this numerator will cancel with this denominator, and you're left with that. This numerator will cancel with this denominator, and you're left with this. Technically over 1, but you don't have to write over 1. Okay, and then you would just go through just like you did from before. The last way that you could have done this is that you could have done cross multiplication. So efficiency and speed is what it's all about. Okay, so if I did this as far as cross multiplying, that is a long way because I have x plus 2, x minus 1, and then whenever I cross multiply this piece, notice that I'm not distributing, I'm keeping it factored. X plus 2, and then x squared plus 2x minus 3. And from here, I could say, okay, now I just have denominators of 1. So if I were to divide both sides by whatever I could that they both have in common, those cancel, and those cancel. So I'm still left with this step. So there's different ways that you can do it. To me, if you do cross multiplication, just understand, please don't distribute. You're going to have to refactor anyway, and you're creating yourself a mess and a whole mess of extra work. Okay? You can either look at it as, they're the same, they're negligible. Now let's just compare the numerators, which is how I started this problem as. Or you can multiply by the LCD. Still going to be the same thing. Please, please, please always check for reasonableness by plugging in your answers into the original question. And if you get zeros for any of those answer pieces, those are extraneous, non-valid answers, so we won't include them as our final answer. Okay, so one more for this part of the video. Solve the rational equation. Now, I know it didn't copy over. No worries. I'm going to go ahead and copy that over right now from the notes. 3 over x plus 2 plus 6 over x squared plus 2x. And it's equal to 3 minus x over x. All right, so now we are going to be efficient with this, okay? Because if we did the cross multiplication the way I did this last problem at the very end, we need a fraction is equal to a fraction. I don't have that right now. I have 2 fractions on the left. So we can't do this cross multiplication. But again, I don't think we should ever do this cross multiplication. Okay, some people use it and that's okay. But for this context, I don't think we should. I think we should just go straight for the LCM. Okay, but you got to remember what you're doing for that. So the first step is to identify what are the factors. So I can say what is the least common denominator with those factored pieces. Okay, so let's go ahead and copy all of this over. See, I'm going to put it right here. And now I'm going to go ahead and factor out all the pieces that I know that I can factor. Well, this is GCF'd as x times x plus 2. Now, let's look at all of our denominators. Well, I have an x here. I also have it here, but I don't have it here. So I know x is going to be part of my LCD, otherwise LCM. Okay, this is how you develop an LCM, by the way. Well, the first one had x plus 2, so does this one, but this one doesn't have that. So that too will be part of my LCM. Remember, whatever, as you're doing this and you're listing them all out, these will all be multiplied together as one huge term, okay? So that means if I come over here, let me go ahead and make another copy so that you can see what I'm doing. All right, so let's go ahead and, let's multiply by our LCM. That means everything is going to be multiplied by this LCM, which is x times x plus 2 all over 1, okay? So if I have this huge, let's say parentheses or bracket, I'm distributing this across all three pieces. Okay, let's do the first one. When I distribute this with the first one, those will cancel and 3x is left over. Okay, so let's go ahead and write that as 3x over 1, but I'm just going to leave it as 3x. Now, when I distribute this on the second one, those will cancel. And also this will cancel. So that all I have is an understood 1 over 1 times 6. So I'm going to have plus 6. And I'm going to put that in parentheses. Again, because of good practice, this might sometimes be negative. And I don't want to miss those negative pieces. Now, whenever I distribute this last fraction, x will cancel with x, and that's it, so that x plus 2 and x, or 3 minus x, are left over. Again, I'm not going to distribute just quite yet. But notice, what the LCM, aka LCD, does is it gets rid of all of these nasty denominator pieces to where you just have this regular Algebra 1 level equation, if you will. Okay, Algebra 2 because there's quadratic here, but you know what I'm talking about. They're all over 1 per se. Okay, and that's easy to interpret and go ahead and just solve using basic kind of algebra. Okay, so we have 3x plus 6, that goes away, and then we can distribute this. Okay, so let's go ahead and distribute this, and then we'll factor and find our solutions. We have 3x, we have negative x squared, then we have plus 6, then we have minus 2x is equal to 3x plus 6. Okay, so let me go ahead and make this different colors so that you can see the right side versus the left side a little clearer. And now we just recognized just now that we have an x squared. So this is not necessarily algebra 1. We have to do some kind of factoring even more so from here. Okay, so let's factor this piece. Well, we're going to combine everything in equal to 0 because we have an x squared and we have a b term as far as all of these x's are concerned. And whenever I'm saying a term, b term, and c term, guys, I'm referring to, which you will pretty much until you finish calculus, to this standard form of the quadratic, okay? If you have an a and a b term, you must set it equal to 0, okay? You cannot get away from not setting it equal to 0 because you will forget certain factors. And we talked about that back in, I believe it's unit 4, whatever it was with quadratics. Don't forget all of your answers. Don't divide half of your answers out. All right, so let's go ahead and move this x squared. I like to have positive x squared pieces. And this tells me I'm going to move it to the left side, so I'm going to move everything to the left side, okay? So if I subtract this 3, those cancel, so those go away. If I add this 2x, I have a positive 2x over here on the left side of the equal sign. I have a positive x squared. And when I subtract this 6, I get 0. And then I have 0 left over. Now, I know this 0 isn't necessary, but it was necessary for us to move this all to one side because we might, if we had it like this per se, we might divide by x. And if we divide by x, we have x is equal to -2. And that's not just the only possible answer. We just got half of our possible answers. So we have to be careful of what we do here, okay? We have to set it equal to 0 here because we will GCF. Huge, huge, huge. A lot of people forget this and they miss it in pre-cal and calculus, okay? Let's try to fix that by fixing that right now in Algebra 2. So if I GCF an x, we'll have this left over. And now, because it's multiplication, we're setting each of these pieces equal to 0. That one, as well as this one. And we know how to solve basic quadratics from here. X is equal to a -2, and x is equal to 0. But we have to check solutions. Just because we have solutions, don't box it and say, oh, these are our final answers. We have to check solutions. So if I plugged in 0 into my original, well, I could get 2. That's legal. Okay. If I put 0 and 0 here, I would have 6 divided by 0. That is not legal. Okay, that's going to be undefined. Okay. Remember, when you plug it back in, the denominator cannot become 0 because you cannot divide by 0. So 0 is not an answer. Let's check -2. If I plug in -2, whoops, it won't work because it's making this denominator 0. Okay, so even though we got answers, they're both invalid. So we're going to put no solution. Okay, so no solution will exist as far as that goes. And then another way that you could have done that is in the graphing calculator. If you put this as your first function, let's say y1, and you put this as your second function, or even if you put it in Desmos, what this is saying is there aren't any intersections between those two pictures. They will not intersect. Thus, you don't have a solution. Okay, so that's the LCD, LCM, guys. Learn it, get efficient with it. I promise you will see that a lot. Otherwise, you're doing things the long and hard way. And those tests are designed that, if you are efficient and know your stuff, you can finish in time and with enough time to double check. Otherwise, it's very difficult to finish said PSAT, SAT, and ACT. So learn it, learn it, learn it. This is highly, highly important.